Hi guys, welcome to today's lecture. Today we start bivariate analysis. So far we have covered different univariate descriptive techniques such as frequency table, graphical techniques, and numerical techniques. Today we start with bivariate analysis. In almost any kind of study, we are interested to study the association between two or more than two variables. For instance, we might be interested to study whether male and female students are having different preferences over subjects of physics and biology. For example, is it that female students are interested more in biology, or we might be interested to study the association of price and demand for a good in a particular market. Is it that with increase in the price, the demand for that good decreases, and by how much? Or we might be interested to study the association of age and mobile preferences. Is it that people in different age groups have different preferences for mobile? In each of these examples, you see that we are having two variables involved. In the first example, we have gender and preferences over physics and biology. In the second example, we have price and demand. In the third example, we have age group and mobile preferences. The statistical techniques that are used to study the association between two variables is that we are referring to as bivariate analysis. That means bivariate analysis is a set of statistical techniques that we use to study the association between two statistical variables. Now, what do we mean by association? When two variables are associated, how can we know that the two variables are associated? So let's start answering these questions. Consider two variables x and y. We say that x and y are associated if their values are related. Remember guys, when we are talking about the values of x and y, we are referring to the data that we have collected on them. For example, consider a company having a lot of employees. We are surveying a sample of employees of this company, and we collect data on two variables, namely gender and salary. Suppose we classify the salary as low, medium, and high. If the number of males and females were equal in all three salary groups, then we say that there is no association between gender and salary. But as soon as the number of male and females were different in the salary classes, for example, if we have more males in the high class salary, then we say that there is an association between gender and salary. When we can carry an association analysis, in order to draw meaningful conclusions, our analysis of association between two variables should be based on a theory or predefined hypothesis. For instance, the theory says that wage and spending are associated. To test this theory in certain population, we collect data on the two variables and analyze the association. What do we mean by analyzing the association between wage and spending? We check whether as we change wage, does spending change or not? Or as we change spending, does wage change or not? Or one claims that gender and GPA are associated. This means that the GPA of male and female students are different. To test this hypothesis, we collect data on GPA and gender of students and analyze their association. If the values of GPA were different for female and male students, then we say that this hypothesis is true. Note that technically we can study the association between any two variables in our dataset, but we must make sure that we choose the two variables for studying their association based on background theory or hypothesis. We cannot just choose any two variables to study the association. They might be statistically associated, but there is no theory or hypothesis that's supporting that association. In bivariate analysis, like univariate analysis techniques, we have different analysis techniques to study the association between two given variables, starting with two-way tables, graphical techniques, and numerical techniques. This is kind of identical techniques that we had for univariate analysis. We had frequency table, graphical techniques, and numerical techniques. Now in bivariate analysis, we have two-way table, different graphical techniques, and different numerical techniques. Depending on the type of two variables, we can use one or more of these techniques. Note that these techniques are used to analyze the association between two variables. Depending on the type of two variables, we can have one of the following cases when we study the association. We can have two qualitative variables, we could have two quantitative variables, or we could have one qualitative and one quantitative variable. Depending on the case, different bivariate analysis techniques are used. Now let's start our bivariate analysis with introduction of two-way tables. Two-way table or contingency table is the frequency table of two variables. In two-way table, we count the frequency of one variable for each value or class of the second variable. Consider this example here. In this example, we have collected data on the gender of 100 students and their preferences of baseball, basketball, and football. Now, this is an example of two-way table for gender and sport of interest. This contingency table or two-way table helps us to study the association between the gender and sports of interest. Now let's start with a two-way table for two qualitative variables. Suppose we have x and y as two qualitative variables. Their two-way table consists of their joint frequency. This is one example of the two-way table for two qualitative variables.